Neptune, our solar system's most distant planet and the smallest of the gas giants. A swirling ball composing of thick water, ammonia, and methane, Neptune appears calm, peaceful, and colorful. But inside of its clouds is a completely different story. The planet's interior is very cold. With a temperature of minus 373 degrees Fahrenheit, it is the coldest object in our solar system and is home to some of the most violent storms we could even imagine. The white bands of clouds you see here are where these storms are located, hugging Neptune like a belt. These storms are fueled by supersonic winds that move over 700 miles an hour and as fast as 1,200 miles per hour, faster than the speed of sound here on Earth. The atmosphere of Neptune is made up mostly of hydrogen, but contains a mixture of helium and methane. Methane gas clouds specifically are found in Neptune's upper atmosphere, and the planet owes its vibrant blue color to its presence. Neptune not only absorbs the red rays from the sun, it reflects them back into space, preserving the blue shade we see. On August 25, 1989, Voyager 2 came within 3,000 miles of Neptune, soaring over its northern pole. This picture was taken just 5 days before what would be Voyager's closest approach. For Voyager to still be that far away but able to capture such a clear and full picture of the planet perhaps gives you an idea just how extremely massive a celestial body like this truly is. The most prominent feature, of course, is Neptune's dark blue spot, or dark vortex. Scientists believe that this vortex is the result of broken cloud structures in Neptune's atmosphere, causing the visual distortion and darker color. Essentially, what we are most likely seeing are the lower cloud decks of Neptune's inner structure. The dark vortex is estimated to be the size of our Earth, or was, but the blue spot captured by Voyager 2 had disappeared by the time Hubble turned its lens towards the planet 5 years later. Unlike Jupiter's Great Red Spot, which has raged for hundreds of years and never moved from its regional position, Neptune's blue vortex seems to disappear and reappear every few years, and reforms in both the north and southern hemispheres. The weather of Neptune is just as mysterious as it is chaotic. Neptune orbits the Sun at an axis tilt of 28 degrees, which means that the icy gas giant actually experiences seasons. One day on Neptune only lasts 16 hours, and 1 year lasts 60,000 Earth days. It takes 165 years for it to complete one orbit around the Sun, resulting in each of its 4 seasons to last for 40 years. The presence of such a high concentration of carbons existing in an environment like Neptune's and its immense pressure has led to the belief that an extraordinary occurrence takes place inside of Neptune's frozen methane clouds. In 2020, an experiment was conducted at the University of Stanford where the conditions of Neptune's environment were recreated. Researchers used polystyrene, a material consisting of carbon and hydrogen, and put it under severe heat and pressure. Under a microscope, the polystyrene split into 2 atoms, resulting in carbon turning into diamonds. If we were able to look inside of Neptune's clouds, we would witness diamonds raining from the sky. One of Voyager's first confirmations was that Neptune does in fact possess a ring system, something that had only been hypothesized since its discovery in 1846. Neptune's rings are made of carbon more akin to coal or charcoal, and is the reason we couldn't be sure they were even there. Since these rings are essentially dust, and being so far away from the Sun, there is not enough light to reflect their visibility back to Earth. The very same reason we had no idea Jupiter had rings until Juno arrived there. There are a total of 5 very distinct rings: Gall, Leverrier, LaSalle, Arago, and Adams, named after the astronomers that discovered and provided research about the planet. We believe rings are formed one of 2 ways, by either leftover material from a planet's formation, or are perhaps the result of a moon that was destroyed when it got too close to what is known as the Roche limit, which is a point where a smaller body of mass can no longer withstand the strain of a greater tidal force. A feature of the Adams ring are 5 unusual and bright arcs named Liberty, Equality 1 and 2, Fraternity, and Courage, which was the motto of the French Revolution. The arcs are most likely made up primarily of ice particles rather than dust. Ice would naturally be more reflective of sunlight rather than rock or heavier material. Therefore, the presence of the arcs would become the result of gravitational clumping. There are a total of 14 moons that orbit the ice giant, named after various sea gods in Greek mythology: Naiad, Thalassa, Despina, Galatea, Larissa, Proteus, and Hippocamp. Proteus and Hippocamp orbit closest to Neptune. The first 4 of these both orbit between the rings of Gall and Leverrier, Galatea in the Adams ring, and Despina in the Leverrier ring. This is Saturn's F ring, but for the purpose of visual demonstration, I will use this as an example to explain my next subject. Neptune's rings are directly influenced by the orbits of its moons, meaning that they are classified as shepherd moons. More definitively, the term shepherd moon is when a moon's gravity precisely defines a ring's width, arc, and formation, essentially keeping its clear boundary intact. As a moon moves through its orbital plane, it pushes dust and debris outward or just absorbs it. Seen here is a large concentration of dust on both sides and between the outer rims of 3 of Neptune's rings. Saturn's moon Prometheus is actually pulling material out of the F ring, essentially replenishing and redefining the ring's shape. We can't know for sure if the same occurs on Neptune, but if we are to go on the information Cassini provided about a planet's rings in general, then it's safe to assume that this is very likely elsewhere. There is no sound in space, but if we were able to visit Neptune, equipped with the tools to translate the electromagnetic vibrations of the planet into sound, it might perhaps sound a bit different than what you would imagine. This is exactly what Voyager 2 did. The probe was equipped with plasma wave instruments designed specifically to capture the sound of the planet. I can't confirm that this is even true, but in Elite Dangerous, I believe it's assumed that the ambient sounds we hear when approaching such an entity are from the same type of instruments on our ship that allow us to detect large planes of gravity and potential danger zones. In the game, this is what Neptune sounds like. This is what Voyager 2 actually recorded. The audio distortions of signals being interfered with by Neptune's magnetosphere eerily resemble those of an old transistor radio when a signal is not strong enough to pick up a certain channel, or of the howling winds of a winter storm that accompany a severe blizzard. And yet still, only basic knowledge of Neptune is actually known, and unfortunately there are no future plans to return to this majestic ice giant anytime soon. But what Voyager 2 provided us was captivating in its own right. I can't begin to imagine how helpless the astronomers in 1846 felt when they discovered it. Neptune was only found by pure hypothesis, and is still the only object that was mathematically discovered before it was physically viewed. That is truly incredible. This picture of Neptune, captured by the James Webb Telescope, was taken just 3 days prior to the publication of this video, which oddly enough I began working on a week and a half ago. Quite a strange coincidence, I must say. The bright blue glow is Triton, which I will discuss in depth in a future video. I had planned to include it here, but felt that Triton more than deserved its own segment. I had a lot of fun making this, and it re-taught me things I had even forgotten. As always, thank you for watching.